This is technically section 6.3, and the title is called Elimination Method, and it's also called Linear Combinations Method. It's also known as Linear Combinations Method. Some teachers refer to it as elimination, other teachers as the Linear Combinations Method. Okay. Now, if we take a look at the handout that we just have passed out to us, the first section is telling us to solve the systems by substitution, right? And you should know how to do substitution, but let's not do that, right? Let's jump right into the actual lesson. Substitution is really simple. You just plug in whatever, this already has y by itself. You plug in the 2x into the other equation into the y. But let's jump right into today's lesson, solving using the elimination method, also known as linear combinations method, okay? So we have all these steps with the optional fifth step of double checking, I think. But it seems complicated, but it's really simple once you get the hang of it. So step one is to make sure that it's organized. It says make sure the x's are on top of the x's, y's on top of y's, equals on top of equals, number on top of numbers. So if we take a look, let me actually do number 3 that we were supposed to do with substitution, and let's just verify step 1. Is it organized? Do you have x's on top of x's, y's on top of y's, bless you, equal on top of equal, and number on top of number? Yeah. Yes, it's organized, right? So we can move on to step 2. What is step 2? It says multiply one or both equations by a value so that either an x or a y cancels out when you combine the lines. You may not have to do this step. The system might be already ready to combine and cancel. So if we look at this system that we were supposed to do with substitution, let's think about the title. It says linear combinations. If I combine x and 3x, will it cancel out? No, that'll give us a 4x. If I combine 4y and 5y, will it cancel out? No, that'll give me a 9y. Does that make sense? Your goal of combining the lines, your goal is to eliminate either the x's or the y's. Okay, this is the first time you see it. Pay attention, understand it, and then you'll be able to own it, right? Okay, so if I combine the lines, the x's don't cancel. I want something to eliminate. That's why they call it elimination method. So what would I need right here in order for the x's to actually eliminate? A 3 right here would give me 3x plus 3x. That wouldn't eliminate. That'd give me a 6x. What would I need right here? A negative 3. Does everybody agree that if this x were a negative 3x, it would eliminate, right? Okay. The beauty of an equation is that you could do whatever you want to an equation as long as you do it to the whole equation. So I could change this x. I could make it a negative 3x. How? By multiplying the whole thing by negative 3. So everybody go to that problem that you were supposed to do with substitution, put parentheses around the top equation, and put a negative 3 out in the front. And we're actually going to multiply everything by negative 3 to get a new equation. And I'm going to draw an arrow this way, and I'm going to show my new equation. When I go negative 3 times x, that'll give me a negative 3x. When I go negative 3 times positive 4y, that'll give me a negative 12y. When I go negative 3 times negative 4, that will give me a positive 12. There's my new equation. Does that make sense? Now, why the heck did I multiply everything by negative 3? What for? To get the x's to eliminate, right? Like originally x and 3x, that won't eliminate. X plus 3x is 4x. But now that I modified it, this one I don't have to modify anything. I'm just going to rewrite it. So I'm just going to rewrite it right below, organize 3x plus 5y equals 2. Now it is ready to combine the lines. Now it really is ready to eliminate. That's where the title comes from. Linear combinations and elimination method. I am going to combine the lines. What happens to the x's? They cancel out. They eliminate. So I'm going to put a line right through them. And how about negative 12y and positive 5y? When I combine those, what do I get? Negative 7y. Okay, and the equal sign, you just bring it down. And over here, when I combine 12 and 2, what do I get? 14. Okay, so that's the first step. You may have to modify one or both equations to get either an x or a y to cancel. Do we understand that first step? Now, believe it or not, everything else is cake from here. Because if you look at what you just did, you modified the top, you combined it. What do you have here? You have a single step equation in blue. It's a one-step equation. How do you solve this?
Negative 7 divided.
Yeah, since it says negative 7 times y, divide by negative 7, divide by negative 7, and guess what? You have your answer. X or y equals negative 2. Pretty cool, huh? And back before with substitution method, once you had one answer, how do you find the other answer? Anytime you have one answer and you want the other answer, all you got to do is plug it back in and solve, right? So take that answer, y equals negative 2, and plug it back in anywhere you want of the original equations. I want to do the top equation. The top one says x plus 4y equals negative 4, but instead of y, I'm going to put parentheses, right? So it's going to say x plus 4 parenthesis equals negative 4. Now, why did I put parentheses? Because I know that y equals negative 2. I'm actually going to plug in that negative 2 right there where the y is at, which means the negative 2 is going to go inside of the parenthesis, which means I could actually do this math. X, what is positive 4 times negative 2? Negative 8. Bring down the equal sign, bring down the minus 4. I want to now get x by itself, add 8 to both sides, and you get your answer, x equals positive 4. So our answer to this system, x is 4, y is negative 2. Now let's say you weren't too certain about what we just did. You could always plug in the x value of 4 and the y value of negative 2 right in there. Work it out, it should work. Plug in the x value of 4, the y value of negative 2 right there, work it out, it should be a true statement. Anyway, you just observed me do that the first time. We didn't even read through the steps as we went through it. Let's actually take a look at the steps again. Step 1, make sure it's organized, right? X is on top of x's, y is on top of y's, equal on top of equal. If it's not organized, you could move things around and organize it, okay? Step 2, you may have to multiply one or both equations to get something to cancel. Like right here, we only multiplied the top equation by negative 3. That's because we decided to cancel out x's. Now, if you would have said, no, I want to cancel out y's, okay, you could do that, but you would have to change this to become a 20y, and you would have to change this to become a negative 20y. Does that make sense? To get exact opposite values. So you could cancel out y's, but in that case, it would be a little bit more work. You'd have to multiply the whole top one by positive 5 to get a 20y. You'd have to multiply the whole bottom one by negative 4 to get a negative 20y. That way the positive 20y would cancel with the negative 20y. But that's not the case here. We went with the easiest path, canceling out x's by modifying only the top equation by negative 3. Now sometimes you're going to have to modify both equations. But sometimes it's ready to rock. Like take a look at this one right here. That one, do I have to modify anything? Heck no. It's just ready to combine the lines and eliminate. If I combine the lines, what happens?
Y is canceled out.
Yeah, 5 and 3, it doesn't cancel. It's 8x. The negative 6y and the positive 6y, that eliminates. It's gone. So what I really have is 8x equals, and what is negative 32 plus 48? You could use a calculator if you want. 16. So believe it or not, we have a simple one-step equation now. Dang, isn't this easy, right? Of course, I should have gone through the steps. What's step 1? Is it organized? Yeah, it's organized. If I combine the lines, will something cancel? Yeah, something cancels. I combine it. I have this new simple one-step equation. How do I get rid of the 8 in front of the x? It's really saying 8 times x. So yeah, you're going to divide by 8 to get rid of that multiplication of 8. Divide by 8, well, you do to one side, do to the other. What's your first answer? X equals 2. How do you find the other answer? Just plug it in and do the math and you're done, right? Super, way the heck more easy than solving with substitution. Way the heck more easy than solving with substitution. But anyways, let's finish this. Let's actually plug in the x value of 2, anyone you want, top or bottom, doesn't matter. Top, okay, so the top one says 5x, but I'm going to put 5 times 2 because x is 2. Top says minus 6y equals negative 32. Are you with me? All I did was take the x value of 2 and plug it in right there. Why is that? Because it said 5x, there it is 5x, but x is really 2, plug in the 2. Let's do the math. 2 times 5 is 10, 5 times 2 is 10. Minus 6y equals negative 32. You want to solve for y, what do I get rid of? 10. Subtract 10, cancels out, subtract 10. We end up with a negative 6y equaling a negative 42. Final step is to get rid of that multiplication of -6 by dividing by -6, dividing by -6, and we will get y equals 6 times 7 is 42. A negative divided by a negative is a positive. Y equals 7. So your answer, 2 is x, 7 is y. The coordinate 2, 7. Like I said, this is a heck of a lot easier than substitution method, okay? Now you might be thinking, then why the heck did he teach us substitution? Because sometimes it's ready to substitute. Like if you had the top equation that said y equals some stuff, then yeah, you could plug that into the y and it would be pretty easy to substitute. But if most of the time they're not ready to substitute, so linear combinations is most of the time the fastest method, okay? How about number 2? What do you think of that one? Is that ready to combine the lines, or do I have to modify something? It's ready to combine the lines, right? So let's do that. Let's put a line and let's combine the lines. What's 7x take away 7x? It cancels out. It eliminates. How about the 2y plus 1y? 3y. How about 10 plus -16? -6. Now, we understand that we combined the lines because these eliminated. If this would have been a positive 7x, it wouldn't have eliminated. I'd have a 14x down here, which means I'd have to modify either one or both equations to get something to cancel. But right now it was ready to rock. It's ready to eliminate. The x is canceled out. You have 3y equals -6. What does y actually equal? If I solve this simple one-step equation? Divide by 3, divide by 3. Yep, y is going to equal -2. I have one answer. I need the other. How do I do it? How do I do that? Plug it into which one? Doesn't matter. Pick one. Top or bottom? Top. Okay, top one reads 7x, and I don't have x. I have a y, plus 2. Since I have y, I'm going to put parentheses instead of y equals 10. Okay, there it is. 7x plus 2y equals 10. 7x plus 2y in parentheses equals 10. What am I plugging into the parenthesis? -2. Put it right there. -2. So I now have 7x minus 4 equals 10. I need to solve this thing. Add 4, add 4. I have 7x equals 14. How do I get rid of the 7? Divide. That's right. Divide by 7, and you'll get your final answer, x equals 2. So how are we going to write the answer? Coordinate format, x first, +2, y second, -2. So 2, -2 is the answer to this system. Anytime you're taking a quiz or test and you get an answer and you want to double check it, you could always plug in the 2 for x and the -2 for y. Think about that. 7 times 2 is 14. 2 times -2 is -4. 14 take away 4 really is 10. Double checked it. 2 right there, -2 right there. -7 times 2 is -14. Plus -2. -14 plus -2, it really is -16. Double checked it. Hands down, absolutely confident that this is the correct answer. You could bet your life on it. Fun stuff, right? Is this one ready to combine and cancel? No, that kind of sucks, right? If I combine these, it gives me 6x, it didn't cancel. I combine these, that'll give me a 36y, it definitely doesn't cancel. So I need to modify maybe one or maybe both equations depending on what you think you want to cancel. What do you think is easier to cancel, x's or y's? Y's. All I have to do to get the y's to cancel is what? -1. Change one of the equations by multiplying by -1. I'm going to take the bottom equation, and everybody should do this, put parentheses around it, put a -1 down here. So we're not going to mess with the top one. Now the reason why I'm multiplying by -1 is because if that -1, when I distribute it, it's going to change all the signs, making this a -18, which will then cancel with the +18. And that's what I want. I want something to eliminate, either x's or y's. So the top equation I'm not messing with, I'm just going to rewrite it. And the bottom equation becomes what? Anybody? When I multiply everything by -1, it changes all the signs. Read it to me.
-4x minus 18y equals 27.
That's right. Just change all the signs. And now it really is ready to combine and eliminate those y's. So the x's don't eliminate. What's 2 take away 4? Right here, guys. What is 2 take away 4 on the x's? -2. Okay, so let me put -2 right here. -2 with an x. And yeah, the 18 and the -18 on the y's eliminate. And the equal sign comes down. And the -9 plus 27, that's like 27 take away 9. That's going to be 18, correct? Use a calculator if you need it. Final step, divide by -2 to solve that blue equation. That says -2 times x. So the way to get rid of multiplication of -2 is to divide by -2. What you do to one side, do to the other side, and you will get x equaling -9. That is one answer. You need the other answer, plug it in. Any one you want, top or bottom?
Top.
Top. Top sounds good, or bottom, whatever you want. I'm going to go with the top. The top says 2x, but since I know x, I'm going to plug it in with parentheses, plus 18y equals -9. That's the top equation. The only thing, instead of x, I'm putting parentheses. That way I could actually plug in my x value of -9 right in there. And when I do the math, 2 times -9, that's -18, plus 18y equals -9. What do I do next to solve for y? Get rid of the 18 by adding 18. Adding 18, the opposite of -18, that is. So what do I have left? I have 18y equaling a positive 9. And for my final step, what do I do? Divide by 18. Divide by 18. Now, unfortunately, right here, we don't get a nice number. 9 divided by 18, you can't actually divide 9 by 18. You could reduce 9 over 18. You could reduce both top and bottom by 3. And that'll give you y equals 9 divided by 3 is 3, and 18 divided by 3 is 6. Wait, why am I dividing by 3? I should just divide by 9, right? 9 over 18, reduce both by 9, and you'll get 1 over 2, 1/2. 9/18 reduces down to 1/2. So this is your y answer. So y equals 1/2, or you could say y equals 0.5, whatever you like. Anyway, the answer in coordinate format will be parenthesis, the x value is -9, the y value is 1/2. Or you could write it -9, comma 0.5. Either one of those will be correct if you do it on the quiz. Last one on the notes. So is this ready to combine and eliminate? No. What do I need to do? Do you want x's to eliminate? You'd have to multiply everything by -7. Or do you want y's to eliminate? You'd have to multiply everything by what? Okay, so what we're doing right now is looking at the different roads. Which one's the easier path, right? If I want to cancel out 7x, what does this have to be? It has to be a -7x. Or if you want to cancel out the positive 15, what does this have to be? A -15. Could you change -3 to become -15 with multiplication? The answer is yes. How do you do that? Multiply everything by what? By 5. So it's either you multiply the bottom one by -7 to get the x's to cancel, or multiply everything by +5 to get the y's to cancel. I'm going to go with canceling out y's by multiplying the bottom equation by +5. You see, when I multiply by +5, 5 times x is 5x. 5 times -3y is -15y. 5 times 20 is 100. And the top equation stays the same, 7x plus 15y equals 32. And now it really is ready to combine and eliminate those y's. That's why I modified the bottom equation by 5 to get the y's to eliminate. This is where it actually eliminates. They disappear. What is 7 plus 5 when I combine those x's? That is 12 with an x. Bring down the equal sign. What's 32 and 100? That's 132. All I need to do now is solve that simple one-step equation by dividing by 12, and I will get x equals, I believe that's 11. We have the x answer, we need the y answer, all we got to do is plug it in. I'm going to plug it into the bottom equation. The bottom equation reads x, but I know that x is 11, so I might as well write 11 minus 3y equals 20. This is the bottom equation. And instead of x, I wrote 11 because x equals 11. I didn't show my work. I probably should have. But anyways, this is a simple equation. 11 minus 3y equals 20. All I need to do now is get rid of the 11 by subtracting 11. Subtracting 11. My new equation will read -3y equals 20 take away 11, what is that, 9? And then we're finally going to get rid of the minus 3 that's being multiplied in front of the y. To get rid of multiplication, you divide. What you do to one side, you must do to the other, giving you y equals negative 3. So the answer to this last system is 11 comma negative 3. And of course you could double check it by plugging in your values into both equations of the original system. Okay, so right here we have the worksheet on substitution, right? The worksheet on substitution, and I already taught you elimination method. Now, elimination method most of the time is the fastest, and I would always use the elimination method if my system is lined up. X is on top of x's, y is on top. Like right here, I would use elimination method, right? Because the x's are lined up, the y's are lined up, the equals are lined up, right? I could easily cancel out this x with these 3 x's if I multiply the whole top one by what? By what? By negative 3. Might as well, I mean, just watch me. I don't know if you already did this with substitution, but if you distribute that negative 3, that'll give you a negative 3x, it'll give you a negative 15y, it'll give you a negative 3 times 4 is negative 12. The bottom equation stays the same, and it is now ready to eliminate those x's. But then again, the y's also eliminate, and you end up with nothing equals negative 13. What do you think about that? Is 0 equaling to negative 13? Never. So what do I say? No solution. Now, that was a heck of a lot faster to do than substitution method, right? I could have decided to subtract 5y, x equals a variable expression, plug that all into x, distribute 3, combine like terms. It's a lot of work. Linear combinations is way, way better, way, way faster. Now, like right here also, I'd multiply the top equation by negative 2 to get the x's to cancel. Down here, I'd probably multiply the bottom equation by negative 2. That way this will become a positive 2, which will then cancel with that one. So all of these where they're lined up, even this guy right here, like that one looks crazy if you're trying to do it with substitution method, because you're going to be plugging in decimal numbers and stuff, right? But if you think about linear combinations and you want to cancel out y's, you could multiply the whole top equation by what? If I want this 2y to cancel out with this one, what does this have to become? Stay with me, guys. What does this have to become in order for it to cancel with the plus 2y? Negative 2y, right? Okay, so how am I going to change this 1y to become a negative 2y? By multiplying everything by negative 2. And if I do multiply everything by negative 2, look how easy this works. Negative 2 times 2.5, that'll be a negative 5 with an x. Negative 2 times positive y, that's negative 2y. Negative 2 times negative 2, that's positive 4. The bottom equation stays the same. And now I'm ready to combine the lines because the y's eliminate. And what we end up with is a negative 2x equaling 4. And you see that you get the answer nice and easy. Divide by negative 2, divide by negative 2, x equals negative 2. You want the other answer? Plug it in, and you'll get the other answer, right? I want to plug it into the bottom equation. 3 times x plus 2y equals 0. So I want to plug in a negative 2 right there. That'll be a negative 6 plus 2y equals 0. Get rid of that minus 6 by adding 6 and adding 6. That'll give you 2y equals 6. Final step would be to divide both sides by 2. Divide by 2, divide by 2. Final answer is y equals 3. So negative 2 comma 3 is your answer for this crazy looking problem. That would be crazy if you would have done substitution, but elimination is way better than substitution. So you're probably thinking, then why the heck did we even learn substitution? Because in reality, you never need to use substitution. You could always go with organizing it and using elimination method. But the reason why we did go through substitution, because sometimes, depending on your system, it's really easy to substitute. Like, for example, right here, you see how you have already y by itself? All you have to do is substitute this guy into that y spot. And you'll have 2x plus, that would be a 3x right in there. And then equals 15, and then you could solve. So if you do have an equation that has y by itself or x by itself, I mean, substitution's a good choice, because the alternative is to rearrange it and put x's on top of x's, y's on top of y's, equal on top of equal, and number on top of number. So for example, on number 5, you might want to substitute by taking x minus 1 and plugging it into the y and doing the math, distributing and combining like terms and solving. But you could also line them up. Like this is not lined up. The equal sign should be over here. So what would we have to do? We'd have to subtract x and subtract x to move it to the left side to get it lined up. Step 1 is to organize it if you want to use linear combinations method or elimination method. But if you want to use substitution and you have a letter already by itself, then go ahead and use that to substitute into the other equation. I apologize for the long lesson. I hope this clarifies when to use certain systems or certain methods to solve systems. Of course, if you had two equations that were both in y equals mx plus b, it might be a good idea to try graphing to see if they cross. Anyways, I'm done. Please work on whatever worksheets you haven't finished.